to today's episode. So we continue looking at the 2021 Grade 12 GCE Mathematics Paper 1. So we've done question 1 through question 21. So today we are looking at question 22 and 23, which is our final episode in this paper. So question 22 reads, the components of vectors OA and OB are column vector 2, 3, and 4, 3 respectively. Write BA as a column vector. So to help you visualize what we're trying to achieve here, let me just sketch something. So we have, this is the x-axis, then this is the y-axis. So from origin to A, we are moving 2 points. So in the x-axis, we are moving 2 units. Then y-axis 3 somewhere here. So we shall call this A, this to be A. Okay, such that this is 3, then this is 2. Then to get to B, we are moving 4 units, which is x is 4 somewhere here. Then we maintain the value of y, which is basically the same. So the value of y now becomes 2. So it's slightly lower, here. So it's like this is B. Then so this is the direction, this is direction. So the question is asking us to find the movement from B to A. This movement B to A. So how can we move from B to A? So the option that are there to get to from B to A, when a B to get to A is 2. So which is B A is basically going back to the origin, which we are calling BO, which is opposite of OB in the opposite direction. So opposite direction is a negative, remember, in vectors, plus then from O to A. You get it? So this is how we are moving. So we know that BO is equal to negative of OB. So what we get is basically negative OB. What is OB? Is 2, then is 4, then 2, then OA is 2, then 3. Then when you add this, so it's a negative times 4, so you get negative 4, then 2, plus basically 2, then 3. So we end up with negative 2, then this is a negative, then 1. Okay, negative 2, then 1. Okay, so in terms of x, we are moving backward by 2 steps, which is negative 2. Then in terms of x or y-axis, we are increasing by 1 unit. So basically, that's the column vector for question A. Let us move to question B. So question B, the diagram below shows a sketch of a graph y is equal to, okay, so let me just zoom in so that you should be able to see properly also. Okay, so y is equal to, y is equal to 5 minus 4x minus x squared. Then find the coordinates of points A and B. So at this point, the value of y is equal to 0. You say where this 2 is crossing the x-axis. So meaning what this tells us, it means 5 minus 4x must 4x minus x squared must equal to 0. So what we get is basically negative x squared minus 4x, then plus. So this one comes in front, then this one goes outside, plus 5 is equal to 0. So since the highest power is a 2, then the second lowest is a 0, then we have 0 and a 1. So this is a quadratic equation. Remember, the highest power here is 2, then we have a 1, then we have here 0, x to the power 0, which is 1 times 5. So in this case, what we get is the product here in this case is negative 5, which is negative 1 in front here times 5, so negative 1. Then the sum is basically negative 4. Then what are the factors? So the factors, we have basically negative 5 and 1. Because negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. So whenever there is negative 4, we substitute with these factors. So we get basically negative x squared then plus x, then minus 5x, then plus 5 is equal to 0. So we factor out x. Okay, so we can factor out there, we can factor out, basically let us factor out x. So we have negative x plus 1. Then we have basically this one we factor out 5. Okay, then we have negative x plus 1 equals to 0. So what you notice is what is in the bracket are the same. So here then we can factor out what is in the brackets, which is basically nothing but 1 minus x. Then x here, when factor out this one, then plus 5 is equal to 0. So what this tells us is either this one is 0 or this one is 0. So 1 minus x is equal to 0, or x plus 5 is equal to 0. Okay, because if anything is 0, 0 multiplied by anything is 0. So what this one tells us is basically x is equal to 1. When this one crosses the equal sign, it becomes a positive. Then this one tells us x is equal to negative 5. Okay, so x is equal to negative 5 is here, then x is equal to 1 is that one. Then after we find that, we need to find the coordinate. So we know that the coordinates there are easier because the value of y there is 0. So at A, okay, so at A, at point A, what we know is at A we have negative 5, 0. Then at B we have 1, 0. 1, 0 as our coordinate. So this is how we find those coordinate, which is A and B. Then let us go to the number 2, maximum value of y. The maximum value of y. So the maximum value of y will occur at the turning point. So this is the turning point. So at the turning point, the gradient of this equation is 0. So let us find the gradient of the equation at that point. Then we substitute in y. So at what point, what's the value of x at which the curve reaches the turning point? So we need to differentiate this function with respect to x. So we have dy dx. dy dx is equal to basically this constant is 0. Changing the constant as a result of changing x is 0. Then the change in this one, so this is the power 1. So 1 times 4, we have negative 4. Okay, then this one minus 2x. Okay, now this change is equal to 0 at the turning point. So what it means, we have negative 4 minus 2x is equal to 0. Then we have negative 4 is equal to 2x. We divide by 2, we divide by 2. So x is equal to basically negative 2. So at this point, when x is equal to negative 2, we have x, the maximum value. So now what the question is asking us to find the maximum value of y. So now for us to find the maximum value, let me use this space. So we substitute in this equation. So we have y is equal to 5 minus the value of 2. Remember, the value of x is a 2. So it's a 4 multiplied by negative 2. Then plus minus. So minus negative 2. So minus negative 2 square. So we have basically 5 minus, so negative 4 times negative 2 is a positive 8. Then minus negative 2 times negative 2 is a 4. 4 times negative, so we have a negative 4. So what it means is we have 5 plus 8, which is 13, minus 4, which is basically 9. So 9. So the maximum value of y, which is y maximum, is basically 9. So at this point, the value of y is 9. So we have at negative 2, 9 as the maximum point. So the value of y is 9. So basically, that's how you answer this part of the question. Let us move to question number 23. So number 23, the question reads, the diagram below is a speed time graph of a moving car. The car D accelerates uniformly from a speed of 24 meters per second to a speed of v meters per second in 3 seconds. It then moves at a uniform speed for the 10 seconds and finally decelerates. Okay, finally decelerates at 3 meters per second square until it comes to rest after t seconds. Then find the speed v if the deceleration in the first 3 seconds was 2 meters per second square. So deceleration in this case, which we shall call deceleration, is given by generally v2, final velocity minus velocity, the previous velocity, over final time t2 minus t1. So in this case, dc is basically 2 meters per, so it's a negative, remember, since it's deceleration, is equal to basically the initial one is 24, the final one is v, we're looking for v minus 24 over the final time is 3 seconds, 3 minus the initial, which is 0. So we have negative 2 is equal to basically v minus 24 over 3. Then this is over 1. So remember, strategy is v. Before you do anything, cross multiply. So we have 3 multiplied by negative 2. We have negative 6 is equal to v minus 24. So collecting the like terms, 24 crosses the equal signs of 24 minus 6 is equal to v. So v is basically equal to 18 meters per second. That's the speed for A. Let us go to B. B leads distance covered in the first 13 seconds. So what we need to do is we need to find the area of this one, then the area of B, then the area of C, then sum those areas. That's what it means. So to find the total distance, maybe I can use this space. So distance in this case will be basically we start with this one. So this is, remember, 18 found. So it's 18 times 3. So 3 times 18, that's the first, the area for A, remember A, then plus the area for B. So the area for B is basically, it will be this is dimension. So it becomes half because it's a triangle multiplied by basically 24 minus 18. So 24 minus 18 is basically the 6, then multiplied by this length, which is 3 seconds, then plus then the area of this rectangle, which is basically as 0, 18 minus 0, which is 18, then multiplied by 13 minus 3, which is 10. We get that. So we are getting 3 times 18. So 3 times 18, we have 4, then we have 54, plus 6 times 3, which is 18, plus multiplied by half, which is 9, then plus 18 times 10, which is 180. Then when we add this, we are going to get basically a 243 meters. 243 meters as our total distance. That's it for C. Or for B, sorry, that's for B. Let us look at C. So C, the value of T. So let me just try to clear the shape so that you're able to see clearly. So the value of T. Okay, so we're looking for the value of T. Okay, so the value of T, so remember the car is finally decelerating at 3 meters per second square. So for us to find the final deceleration, okay, the final T, it would require for it to come to rest. We need to use the same formula that we used here. Okay, so let me just use the lead so that we see the difference. So deceleration is equal to, again, v2 minus v1 over t2 minus t1. So deceleration in this case is equal to minus 3 is equal to, what is v2? So this is the v1, then the final velocity is here, which is 0. So it will be 0 minus where we're starting from, which is 18, then over, then t, the final t, it's t, then minus this t, which is 13. So we get minus 3 is equal to negative 18 over t minus 13. Okay, then this is over 1, we close, so it will be negative 3 multiplied by t minus 13 is equal to negative 18. Then we divide by negative 3, then we have t minus 13 is equal to basically 6. So basically 6. So what t is, so t is basically 6 plus 13, which is equal to basically 19 seconds. So 19 seconds is our answer. 19 seconds. So t is basically 19. So basically this is how you answer question C of 23 to get the 4 marks. So we've come to the end of our revision of 2021 GCE Mathematics paper 1 for grade 12.